Alright, today we're going to be talking a little more about scatter plots, and we are going to be talking about line of best fit today. So you are going to need a ruler and a pencil along with your notes to be able to do this. You can pause your video long enough to go get those if you don't have them already. Alright, so a scatter plot again is a way of displaying bivariate data when both variables are numerical. A line of best fit, which is what we're going to learn about today, is the line that attempts to model the data represented in the scatter plot. Correlation describes if the scatter plot has a positive, negative, or no correlation. This is just the slope, basically the slope of the line of best fit. And an association is if the scatter plot is linear or nonlinear. Okay? Alright, so we're going to take a look at some of these. We're going to describe the line of best fit for each of these scatter plots. And while we're doing this, we're also going to talk about what it would look like if we were to draw the line of best fit. So if I'm looking at the A, I see that I have pant size is my Y values, the height is my X values, and as it increases in height, the pant size also increases, so both of them are increasing. So this is a positive association. If I were to draw a line, I would draw it down through the middle of this, and so it would have a line similar to that. And so it would be a positive sloped line. When I look at B, this one is money in a savings account for my Y values and the money spent. So if you start out high, and then as you spend, what's happening? It's going down, right? So as you're spending money, it's going down. So when it increases here and decreases here, this is called negative. This is not a strong correlation. It's kind of a loose fit. And this is definitely would not be considered to be linear, because if I were to draw a line through that, the dots just don't follow closely with that line, so we can't call it linear. Okay? When I look at C, I see that temperature on my Y's, time is on the bottom for my X's, and it has like a curve to it, doesn't it? So I would not be able to draw a line of best fit for something like this, because no matter how I place my ruler, it doesn't quite fit in the middle. So this would be definitely a non-linear association with this one. Okay. Then let's take a look at D. Number of hours of TV that's watched, that's my Y values. My X values are the age. And when we take a look at this, what type of correlation do you see? If you said no correlation, you are correct. Also, when there's no correlation, you can't draw a line of best fit, because it wouldn't matter which way I put my line. Yes, it could be in the center, but it doesn't really follow a certain rule, does it? So this is nonlinear and is no correlation. Or sorry, no correlation. So we can't do a line of best fit with that one. If I look at E, time taking the test is on the Y, and the grade on the test is my X. And if the more time that I took, did more time that I took, did my grade on my test improve? And so you can take a look at that. I would say that this is neither positive nor negative. It's kind of going straight across. I can do a line of best fit. Looks like it has like a 0 type slope. So if I went across here, I would have a straight line that went left to right. So it's not positive or negative. It's fairly close to it, but I don't know that I would still call this linear. Okay. Then we get to F. We have the emails that were received and the hours worked. So the number of hours worked, the more emails it looks like they got. So it's kind of got a soft positive. I could draw a line through that, and get down through the center, have even number on both sides. But again, I would not call that linear. Okay, next page. We're going to talk about how to draw the line of best fit with these. So first thing we're going to do is plot our points to make our scatter plot. We're going to title it, label it, and then scale it. Okay? So it doesn't look like we have height in feet, and then we have weight in kilometers or kilograms. So this is usually this is my X and this is my Y. So we're going to do that. So this is my height in feet, and this is my weight in kilograms. Okay. And it looks like I have 1, 2, 3, 4. So 1, 2, 3, 4. And then my weight looks like it's going up by tens. So I go 10, 20, 30, 40, and 50 along the side here. So at 110, there's my point. At 220, I have a point here. At 330, and at 440. Okay, so now that we have it drawn, we've got it labeled, we've scaled it, our thing's already there. Is this a positive, negative, or no correlation? And if you said positive, that is correct. Is it linear? Can I take and draw a line and for them to either be on the line or very close to the line? Yes, it is linear. Okay. This is the line of best fit for this one. It goes through the points because they just so naturally lined up like that. Okay. And we can use this to predict that at 6, it would be at 660. It would be real easy to do that. Okay. Okay, let's flip to the next page. And we have the average values of a specific GMC Yukon. We're going to make a scatter plot for this data. We're going to put the age of the car on the x-axis and the value on the y-axis. And then we're going to plot the points. So you go ahead and do that, and I will unpause here in just a moment. Okay, so what I've done is I've labeled my axis. So I have age in years across the bottom. And I started with 1 because it started with 1 here. And I just went every other line and counted all the way up to 11. So I have room for 11 years. And then for the value of the car on my y-axis, and I just did where every box was worth $10,000. Okay, so then I plotted my points, and I get something that looks like this. Now they want to know, does the scatter plot show a relationship between the age and the value of the car? As the car gets older, what's happening to the value? If you said it has a negative association, you are correct. As the car ages, the value decreases. Okay. Now, if I took and drew my line of best fit on here, I would take and I would try to center it as much as I can so that I have an even number of points on both sides of the line. So if I drew it here, I would have 1, 2, 3, 4 on this side, and I would have 3 on the other side. And so that wouldn't work. So if I did it here, I'm going to draw my line. Okay, so this is definitely linear, isn't it? So it is a linear relationship as well. So would I have a positive slope or would I have a negative slope? This would be a negative slope. And so what I want to do is I want to find 2 points that I can use that are on the line. And so I have this one here at 540. And then I have this one here at 820. So I'm going to use those 2 points and I'm going to find my slope. So I have 5 and 40, and then I have 8 and 20. I'm going to use those 2 points and I'm going to find the slope. So when I use my 2 points, I found my slope was 20 over 3. And then they want to know, what does the y-intercept represent? And if I come up here and I look where the y crosses at the x-axis, it says it would be at the 70 point, 70,000. What does that represent? That represents the cost of the car when it was brand new. So now that I've done that, I have everything I need to write my equation. So if we use the slope-intercept form, we know that y equals, our slope is 20 over 3 x, and it started at 70,000. Pardon me, this was a negative 20 over 3. Okay. When do you feel the car would be worthless? If we were to look at our graph and we look to find out when this line would continue down till it hit 0. And so the 0 looks like it comes out for just a little over 11 years. So around 11 years of age. Okay? All right, I know you don't have this one in your notes, but I wanted to show you what it would be like if we were to try to draw a line of best fit for a graph like this one here. So if I were to take this, what I would like to do is to try to figure out what the center of this would be. And we want to kind of follow the group, and we want to go up. And let's see here, we got 1, 2, 3, 4, 5 on this side. If I were to draw that line, I'm going to go ahead and draw that line. Be easier to count it that way. And then I have 1, 2, 3, 4, 5 on that side. So by going through it like this, that finds my line of best fit. Is it possible that someone may have a different line than you? Yes, it's very possible. Okay? Everyone's going to be slightly different, but it should be within the same ballpark. Okay? For this one, if I were to try to use some points, it looks like this would be one I could use. And looks like this one here would be the next one I could use. Even though that's not a point that they're using, you can still use that for your 2 points for finding your slope. Okay? If I take a look at this one, let's get the glare off of it. If I were to find, I think that's the same graph. But anyway, I wanted to show you what that would be like. Okay?